4.8.6 Prevent gameplay cues from firing. Sometimes we don't want gameplay cues to fire. For example, if we block an attack, we may not want to play the hit impact attached to the damage gameplay effect or play a custom one instead. We can do this inside of gameplay effect execution calculations by calling out execution output. Mark gameplay cues handled manually, and then manually sending our gameplay cue event to the target or source's ASC. If you never want any gameplay cues to fire on a specific ASC, you can set ability system component -b suppress gameplay cues equals true. Up arrow back to top 4.8.7 gameplay cue batching. Each gameplay cue triggered is an unreliable net multicast RPC. In situations where we fire multiple GCs at the same time, there are a few optimization methods to condense them down into one RPC or save bandwidth by sending less data. For .8.7.1 manual RPC, say you have a shotgun that shoots 8 pellets. That's 8 trace and impact gameplay cues. JS Shooter takes the lazy approach of combining them into one RPC by stashing all of the trace information into the effect context as target data. While this reduces the RPCs from 8 to 1, it still sends a lot of data over the network in that one RPC, 500 bytes. A more optimized approach is to send an RPC with a custom struct where you efficiently encode the hit locations, or maybe you give it a random seed number to recreate/approximate the impact locations on the receiving side. The clients would then unpack this custom struct and turn back into locally executed gameplay cues. How this works: declare a fscoped gameplay cue send context. This suppresses gameplay cue manager, flush pending cues, until it falls out of scope, meaning all gameplay cues will be queued up until the fscoped gameplay cue send context falls out of scope. Override gameplay cue manager, flush pending cues, to merge gameplay cues that can be batched together based on some custom gameplay tag into your custom struct and RPC it to clients. Clients receive the custom struct and unpack it into locally executed gameplay cues. This method can also be used when you need specific parameters for your gameplay cues that don't fit with what gameplay cue parameters offer and you don't want to add them to the effect context, like damage numbers, crit indicator, broken shield indicator, was fatal hit indicator, etc. https://forums.unrealengine.com/development-discussion/c-gameplay-programming/1711546-fscope gameplay cue send context gameplay cue manager for .8.7.2 multiple GCs on one GE. All of the gameplay cues on a gameplay effect are sent in one RPC already. By default, gameplay cue manager, invoke gameplay cue added and while active _ from spec, will send the whole gameplay effect spec, but convert it to gameplay effect spec for RPC, in the unreliable net multicast regardless of the ASC's replication mode. This could potentially be a lot of bandwidth depending on what is in the gameplay effect spec. We can potentially optimize this by setting the kvar ability system always convert gspec to gcparams1. This will convert gameplay effect specs to gameplay cue parameter structures and RPC those instead of the whole gameplay effect spec for RPC. This potentially saves bandwidth but also has less information, depending on how the GE spec is converted to gameplay cue parameters and what your GCs need to know. Up arrow back to top 4.8.8 gameplay cue events. Gameplay cues respond to specific gameplay cue events. Gameplay cue event description: on active called when a gameplay cue is activated, added. While active called when gameplay cue is active, even if it wasn't actually just applied, join in progress, etc. This is not tick. It's called once, just like on active when a gameplay cue notify _actor is added or becomes relevant. If you need tick, just use the gameplay cue notify _actors tick. It's an A actor after all. Removed called and a gameplay cue is removed. The blueprint gameplay cue function that responds to this event is on remove. Executed called when a gameplay cue is executed, instant effects or periodic tick. The blueprint gameplay cue function that responds to this event is on execute. Use on active for anything in your gameplay queue that happen at the start of the gameplay queue but is okay if late joiners miss. Use while active for ongoing effects in the gameplay queue that you would want late joiners to see. For example, if you have a gameplay queue for a tower structure in a MOBA exploding, you would put the initial explosion particle system and explosion sound in on active and you would put any residual ongoing fire particles or sounds in the while active. In this scenario, it wouldn't make sense for late joiners to replay the initial explosion from on active, but you would want them to see the persistent, looping fire effects on the ground after the explosion happened from while active. On remove should clean up anything added in on active and while active. While active will be called every time an actor enters the relevancy range of a gameplay queue notify _actor. On remove will be called every time an actor leaves relevancy range of a gameplay queue notify _actor. Up arrow back to top 4.8.9 gameplay queue reliability. Gameplay queues in general should be considered unreliable and thus unsuited for anything that directly affects gameplay. Executed gameplay queues. These gameplay queues are applied via unreliable multicasts and are always unreliable. Gameplay queues applied from gameplay effects. Autonomous proxy reliably receives on active, while active, and on remove active gameplay effects container, net delta serialize, calls ability system component, handle deferred gameplay queues, to call on active and while active. Active gameplay effects container, remove active gameplay effect granted tags and modifiers, makes the call to on removed. Simulated proxies reliably receive while active and on remove ability system component, minimal replication gameplay queues as replication calls while active and on remove. The on active event is called by an unreliable multicast. Gameplay queues applied without a gameplay effect, autonomous proxy reliably receives on-remove. The on-active and while-active events are called by an unreliable multicast. Simulated proxies reliably receive while-active and on-remove. Ability system component, minimal replication. Gameplay uses replication calls while-active and on-remove. The on-active event is called by an unreliable multicast. If you need something in a gameplay queue to be reliable, then apply it from a gameplay effect and use while-active to add the FX and on-remove to remove the FX. Up arrow back to top 4.9 Ability System Globals. The Ability System Globals class holds global information about gas. Most of the variables can be set from the default game.ini. Generally you won't have to interact with this class, but you should be aware of its existence. If you need to subclass things like the gameplay queue manager or the gameplay effect context, you have to do that through the Ability System Globals. To subclass Ability System Globals, set the class name in the default game.ini, /script/gameplay abilities.ability system globals, ability system globals class name equals /script/paragon assets.pa ability system globals 4.9.1 init global data, between UE 4.24 and 5.2, it is necessary to call ability system globals get.init global data, to use target data, otherwise you will get errors related to script struct cache and clients will be disconnected from the server. This function only needs to be called once in a project. Fortnite calls it from UAsset Manager, start initial loading, and Paragon called it from UEngine, init. I find that putting it in UAsset Manager, start initial loading, is a good place as shown in the sample project. I would consider this boilerplate code that you should copy into your project to avoid issues with target data. Starting in 5.3 it is called automatically. If you run into a crash while using the Ability System Globals global attribute set defaults table names, you may need to call Ability System Globals get.init global data, later like Fortnite in the Asset Manager or in the game instance. Up arrow back to top 4.10 Prediction Gas comes out of the box with support for client-side prediction, however, it does not predict everything. Client-side prediction in Gas means that the client does not have to wait for the server's permission to activate a gameplay ability and apply gameplay effects. It can predict the server giving it permission to do this and predict the targets that it would apply gameplay effects to. The server then runs the gameplay ability network latency time after the client activates and tells the client if he was correct or not in his predictions. If the client was wrong in any of his predictions, he will roll back his changes from his mispredictions to match the server. The definitive source for gas-related prediction is gameplayprediction.h in the plugin source code. Epic's mindset is to only predict what you can get away with. For example, Paragon and Fortnite do not predict damage. Most likely they use execution calculations for their damage which cannot be predicted anyway. This is not to say that you can't try to predict certain things like damage. By all means, if you do it and it works well for you, then that's great. We are also not all in on a predict everything, seamlessly and automatically solution. We still feel player prediction is best kept to a minimum, meaning, predict the minimum amount of stuff you can get away with. Dave Ratty from Epic's comment from the new network prediction plugin: what is predicted, ability activation, triggered events, gameplay effect application, attribute modification, exceptions, executions do not currently predict, only attribute modifiers, gameplay tag modification, gameplay queue events, both from within predictive gameplay effect and on their own. Montages movement, built into UE's UCharacter movement, what is not predicted, gameplay effect removal, gameplay effect periodic effects, dots ticking, from gameplay prediction.h. While we can predict gameplay effect application, we cannot predict gameplay effect removal. One way that we can work around this limitation is to predict the inverse effect when we want to remove a gameplay effect. Say we predict a movement speed slow of 40%. We can predictively remove it by applying a movement speed buff of 40%. Then remove both gameplay effects at the same time. This is not appropriate for every scenario and support for predicting gameplay effect removal is still needed. Dave Ratty from Epic has expressed desire to add it to a future iteration of Gas. Because we cannot predict the removal of gameplay effects, we cannot fully predict gameplay ability cooldowns and there is no inverse gameplay effect workaround for them. The server's replicated cooldown GE will exist on the client and any attempts to bypass this, with minimal replication mode for example, will be rejected by the server. This means clients with higher latencies take longer to tell the server to go on cooldown and to receive the removal of the server's cooldown GE. This means players with higher latencies will have a lower rate of fire than players with lower latencies, giving them a disadvantage against lower latency players. Fortnite avoids this issue by using custom bookkeeping instead of cooldown GEs. Regarding predicting damage, I personally do not recommend it despite it being one of the first things that most people try when starting with Gas. I especially do not recommend trying to predict death. While you can predict damage, doing so is tricky. If you mispredict applying damage, the player will see the enemy's health jump back up. This can be especially awkward and frustrating if you try to predict death. Say you mispredict a character's death and it starts ragdolling only to stop ragdolling and continue shooting at you when the server corrects it. Note, instant gameplay effects, like cost GEs, that change attributes can be predicted on yourself seamlessly. Predicting instant attribute changes to other characters will show a brief anomaly or blip in their attributes. Predicted instant gameplay effects are actually treated like infinite gameplay effects so that they can be rolled back if mispredicted. When the server's gameplay effect is applied, there potentially exists two of the same gameplay effects causing the modifier to be applied twice or not at all for a brief moment. It will eventually correct itself, but sometimes the blip is noticeable to players. Problems that GAS's prediction implementation is trying to solve. Can I do this? Basic protocol for prediction. Undo, how to undo side effects when a prediction fails. Redo, how to avoid replaying side effects that we predicted locally but that also get replicated from the server. Completeness, how to be sure we really predicted all side effects. Dependencies, how to manage dependent prediction and chains of predicted events. Override, how to override state predictively that is otherwise replicated owned by the server. From gameplay prediction.h up arrow back to top 4.10.1 prediction key. GAS's prediction works on the concept of a prediction key, which is an integer identifier that the client generates when he activates a gameplay ability. Client generates a prediction key when it activates a gameplay ability. This is the activation prediction key. Client sends this prediction key to the server with call server try activate ability. Client adds this prediction key to all gameplay effects that it applies while the prediction key is valid. Client's prediction key falls out of scope. Further predicted effects in the same gameplay ability need a new scoped prediction window. Server receives the prediction key from the client. Server adds this prediction key to all gameplay effects that it applies. Server replicates the prediction key back to the client. Client receives replicated gameplay effects from the server with the prediction key used to apply them. If any of the replicated gameplay effects match the gameplay effects that the client applied with the same prediction key, they were predicted correctly. There will temporarily be 2 copies of the gameplay effect on the target until the client removes its predicted one. Client receives the prediction key back from the server. This is the replicated prediction key. This prediction key is now marked stale. Client removes all gameplay effects that it created with the now stale replicated prediction key. Gameplay effects replicated by the server will persist. Any gameplay effects that the client added and didn't receive a matching replicated version from the server were mispredicted. Prediction keys are guaranteed to be valid during an atomic grouping of instructions window in gameplay abilities starting with activation from the activation prediction key. You can think of this as being only valid during one frame. Any callbacks from latent action ability tasks will no longer have a valid prediction key unless the ability task has a built-in sync point which generates a new scoped prediction window. Up arrow back to top 4.10.2 creating new prediction windows in abilities to predict more actions and callbacks from ability tasks. We need to create a new scoped prediction window with a new scoped prediction key. This is sometimes referred to as a sync point between the client and server. Some ability tasks like all of the input-related ones come with built-in functionality to create a new scoped prediction window, meaning atomic code in the ability tasks callbacks have a valid scoped prediction key to use. Other tasks like the wait delay task do not have built-in code to create a new scoped prediction window for its callback. If you need to predict actions after an ability task that does not have built-in code to create a scoped prediction window like wait delay, we must manually do that using the waitnet sync ability task with the option only server wait. When the client hits a waitnet sync with only server wait, it generates a new scoped prediction key based on the gameplay ability's activation prediction key, RPCs it to the server, and adds it to any new gameplay effects that it applies. When the server hits a waitnet sync with only server wait, it waits until it receives the new scoped prediction key from the client before continuing. This scoped prediction key does the same dance as activation prediction keys, applied to gameplay effects and replicated back to clients to be marked stale. The scoped prediction key is valid until it falls out of scope, meaning the scoped prediction window has closed. So again, only atomic operations, nothing latent, can use the new scoped prediction key. You can create as many scoped prediction windows as you need. If you would like to add the sync point functionality to your own custom ability tasks, look at how the input ones essentially inject the waitnet sync ability task code into them. Note, when using waitnet sync, this does block the server's gameplay ability from continuing execution until it hears from the client. This could potentially be abused by malicious users who hack the game and intentionally delay sending their new scoped prediction key. While Epic uses the waitnet sync sparingly, it recommends potentially building a new version of the ability task with a delay that automatically continues without the client if this is a concern for you. The sample project uses waitnet sync in the sprint gameplay ability to create a new scoped prediction window every time we apply the stamina cost so that we can predict it. Ideally, we want a valid prediction key when applying costs and cooldowns. If you have a predicted gameplay effect that is playing twice on the owning client, your prediction key is stale and you're experiencing the redo problem. You can usually solve this by putting a waitnet sync ability task with only server wait right before you apply the gameplay effect to create a new scoped prediction key. Up arrow back to top 4.10.3 predictively spawning actors predictively on clients is an advanced topic. GAS does not provide functionality to handle this out of the box. The spawn actor ability task only spawns the actor on the server. The key concept is to spawn a replicated actor on both the client and the server. If the actor is just cosmetic or doesn't serve any gameplay purpose, the simple solution is to override the actor's isNetRelevantFor function to restrict the server from replicating to the owning client. The owning client would have his locally spawned version and the server and other clients would have the server's replicated version. Bool API replicated actor except owner, isNetRelevantFor, const a actor asterisk real viewer, const a actor asterisk view target, const f vector and src location, const return, is owned by, view target. If the spawned actor affects gameplay like a projectile that needs to predict damage, then you need advanced logic that is outside of the scope of this documentation. Look at how Unreal Tournament predictively spawns projectiles on Epic Games GitHub. They have a dummy projectile spawn only on the owning client that syncs up with the server's replicated projectile. Up arrow back to top 4.10.4 Future of prediction in GAS gameplay prediction.h states in the future they could potentially add functionality for predicting gameplay effect removal and periodic gameplay effects. Dave Ratty from Epic has expressed interest in fixing the latency reconciliation problem for predicting cooldowns, disadvantaging players with higher latencies versus players with lower latencies. The new network prediction plugin by Epic is expected to be fully interoperable with the GAS like the character movement component was before it. Up arrow back to top 4.10.5 Network Prediction Plugin. Epic recently started an initiative to replace the character movement component with a new network prediction plugin. This plugin is still in its very early stages but is available to very early access on the Unreal Engine GitHub. It's too soon to tell which future version of the engine that it will make its experimental beta debut in. Up arrow back to top 4.11 Targeting 4.11.1 Target Data. Gameplay ability. Target data is a generic structure for targeting data meant to be passed across the network. Target data will typically hold actor/U object references, hit results, and other generic location/direction/origin information. However, you can subclass it to put essentially anything that you want inside of them as a simple means to pass data between the client and server in gameplay abilities. The base struct gameplay ability target data is not meant to be used directly but instead subclassed. GAS comes with a few subclassed gameplay ability target data structs out of the box located in gameplay ability target types.h. Target data is typically produced by target actors or created manually and consumed by ability tasks and gameplay effects via the effect context. As a result of being in the effect context, executions, MMCs, gameplay queues, and the functions on the back end of the attribute set can access the target data. We don't typically pass around the gameplay ability target data directly, instead we use a gameplay ability target data handle which has an internal array of pointers to gameplay ability target data. This intermediate struct provides support for polymorphism of the target data. An example of inheriting from gameplay ability target data, a struct, blueprint type, struct mygame_API gameplay ability target data custom data, public gameplay ability target data, generated body, public, gameplay ability target data custom data, a property, name cool name equals name _none, a property, prediction key my cool prediction key. // This is required for all child structs of gameplay ability target data virtual uscript struct *get script struct, const override, return gameplay ability target data custom data, static struct, // This is required for all child structs of gameplay ability target data bool net serialize, farchive and ar, class u package map map, bool and bout success, // The engine already defined net serialize for name and prediction key, thanks Epic. Coolname.net serialize, ar, map, bout success, mycoolpredictionkey.net serialize, ar, map, bout success equals true, return true, template struct t-struct ops type traits if gameplay ability target data custom data, public t-struct ops type traits base 2 if gameplay ability target data custom data, enum. With net serializer equals true // This is required for gameplay ability target data handle net serialization to work, for adding the target data to a handle, a function, blueprint pure. Gameplay ability target data handle make target data from custom name, const name custom name, // create our target data type, // handles automatically clean up and delete this data when the handle is destructed, // if you don't add this to a handle then be careful because this deals with memory management and memory leaks so it's safe to just always add it to a handle at some point in the frame. Gameplay ability target data custom data my custom data equals new gameplay ability target data custom data, // set up the struct's information to use the inputted name and any other changes we may want to do my custom data cool name equals custom name, // make our handle wrapper for blueprint usage gameplay ability target data handle, // add the target data to our handle, add, my custom data, // output our handle to blueprint return handle, for getting values it requires doing type safety checking, because the only way to get values from the handle's target data is by using generic C/C++ casting for it which is not type safe which can cause object slicing and crashes. For type checking there are multiple ways of doing this, however you want honestly, two common ways are, gameplay tags, you can use a subclass hierarchy where you know that anytime a certain code architecture's functionality occurs, you can cast for the base parent type and get its gameplay tags and then compare against those for casting for inherited classes. Script struct and static structs, you can instead do direct class comparison, which can involve a lot of if statements or making some template functions. Below is an example of doing this but basically you can get the script struct from any gameplay ability target data. This is a nice advantage of it being a struct and requiring any inherited classes to specify the struct type and get script struct, and compare if it's the type you're looking for. Below is // here is when you would do the cast because we know it's the correct type already. Gameplay ability target data custom data custom data equals static _cast if gameplay ability target data custom data data, return custom data cool name, return name _none. Up arrow back to top 4.11.2 target actors gameplay ability spawn target actors with the wait target data ability task to visualize and capture targeting information from the world. Target actors may optionally use gameplay ability world reticles to display current targets. Upon confirmation, the targeting information is returned as target data which can then be passed into gameplay effects. Target actors are based on A actor, so they can have any kind of visible component to represent where and how they are targeting, such as static meshes or decals. Static meshes may be used to visualize placement of an object that your character will build. Decals may be used to show an area of effect on the ground. The sample project uses AgamePlay ability to target tactor_ground trace with a decal on the ground to represent the damage area of effect for the meteor ability. They also don't need to display anything either. For example, it wouldn't make sense to display anything for a hitscan gun that instantly traces a line to its target as used in GAS shooter. They capture targeting information using basic traces or collision overlaps and convert the results as F-hit results or A-actor arrays to target data depending on the target actor implementation. The way target data ability task determines when the targets are confirmed through its TNAM as byte D gameplay targeting confirmation type parameter. When not using TNAM as byte D gameplay targeting confirmation type instant, the target actor typically performs the trace/overlap on tick and updates its location to the F-hit result depending on its implementation. While this performs a trace/overlap on tick, it's generally not terrible since it's not replicated and you typically don't have more than one, although you could have more, target actor running at a time. Just be aware that it uses tick, and some complex target actors might do a lot on it, like the rocket launcher's secondary ability in GAS shooter. While tracing on tick is very responsive to the client, you may consider lowering the tick rate on the target actor if the performance hit is too much. In the case of TNAM as byte D gameplay targeting confirmation type instant, the target actor immediately spawns, produces target data, and destroys. Tick is never called. E-gameplay targeting confirmation type when targets are confirmed instant, the targeting happens instantly without special logic or user input deciding when to fire. User confirmed the targeting happens when the user confirms the targeting when the ability is bound to a confirm input or by calling uAbility system component, target confirm. The target actor will also respond to a bound cancel input or call to uAbility system component, target cancel, to cancel targeting. Custom the gameplay targeting ability is responsible for deciding when the targeting data is ready by calling uGameplay ability, confirm task by instance name. The target actor will also respond to uGameplay ability, cancel task by instance name, to cancel targeting. Custom multi the gameplay targeting ability is responsible for deciding when the targeting data is ready by calling uGameplay ability, confirm task by instance name. The target actor will also respond to uGameplay ability, cancel task by instance name, to cancel targeting. Should not end the ability task upon data production. Not every e-gameplay targeting confirmation type is supported by every target actor. For example, AgamePlay ability to target tactor_ground trace does not support instant confirmation. The wait target data ability task takes in a gameplay ability target actor class as a parameter and will spawn an instance on each activation of the ability task and will destroy the target actor when the ability task ends. The wait target data using actor ability task takes in an already spawned target actor, but still destroys it when the ability task ends. Both of these ability tasks are inefficient in that they either spawn or require a newly spawned target actor for each use. They're great for prototyping, but in production you might explore optimizing it if you have cases where you are constantly producing target data, like in the case of an automatic rifle. GAS Shooter has a custom subclass of a gameplay ability target actor and a new wait target data with reusable actor ability task written from scratch that allows you to reuse a target actor without destroying it. Target actors are not replicated by default, however, they can be made to replicate if that makes sense in your game to show other players where the local player is targeting. They do include default functionality to communicate with the server via RPCs on the wait target data ability task. If the target actor should produce target data on server property is set to false, then the client will RPC its target data to the server on confirmation via call server set replicated target data, in uAbility task_wait target data, on target data ready callback. If should produce target data on server is true, the client will send a generic confirm event, eAbility generic replicated event, generic confirm, RPC to the server in uAbility task_wait target data, on target data ready callback, and the server will do the trace or overlap check upon receiving the RPC to produce data on the server. If the client cancels the targeting, it will send a generic cancel event, eAbility generic replicated event, generic cancel, RPC to the server in uAbility task_wait target data, on target data canceled callback. As you can see, there are a lot of delegates on both the target actor and the wait target data ability task. The target actor responds to inputs to produce and broadcast target data ready, confirm, or cancel delegates. Wait target data listens to the target actor's target data ready, confirm, and cancel delegates and relays that information back to the gameplay ability and to the server. If you send target data to the server, you may want to do validation on the server to make sure the target data looks reasonable to prevent cheating. Producing the target data directly on the server avoids this issue entirely, but will potentially lead to mispredictions for the owning client. Depending on the particular subclass of a gameplay ability target actor that you use, different expose on spawn parameters will be exposed on the wait target data ability task node. Some common parameters include, common target actor parameters definition debug. If true, it will draw debug tracing/overlapping information whenever the target actor performs a trace in non-shipping builds. Remember, non-instant target actors will perform a trace on tick, so these debug draw calls will also happen on tick. Filter, optional, a special struct for filtering out, removing, actors from the targets when the trace/overlap happens. Typical use cases are to filter out the player's pawn, require targets be of a specific class. See target data filters for more advanced use cases. Reticle class, optional, subclass of a gameplay ability world reticle that the target actor will spawn. Reticle parameters, optional, configure your reticles. See reticles. Start location, a special struct for where tracing should start from. Typically this will be the player's viewpoint, a weapon muzzle, or the pawn's location. With the default target actor classes, actors are only valid targets when they are directly in the trace/overlap. If they leave the trace/overlap, they move or you look away, they are no longer valid. If you want the target actor to remember the last valid targets, you will need to add this functionality to a custom target actor class. I refer to these as persistent targets as they will persist until the target actor receives confirmation or cancellation, the target actor finds a new valid target in its trace/overlap, or the target is no longer valid, destroyed. JS Shooter uses persistent targets for its rocket launcher's secondary abilities homing rockets targeting. Up arrow back to top 4.11.3 target data filters. Using both the make gameplay target data filter and make filter handle nodes, you can filter out the player's pawn or select only a specific class. If you need more advanced filtering, you can subclass F gameplay target data filter and override the filter passes for actor function. A struct, blueprint type, struct gas documentation _ API FGD name target data filter, public F gameplay target data filter, generated _ body, /*** returns true if the actor passes the filter and will be targeted / virtual bool filter passes for actor, const a actor to be filtered, const override. However, this will not work directly into the wait target data node as it requires a F gameplay target data filter handle. A new custom make filter handle must be made to accept the subclass, F gameplay target data filter handle UGD target data filter blueprint library, make GD name filter handle, FGD name target data filter, A actor * filter actor, F gameplay target data filter * new filter equals new FGD name target data filter, new filter dash, initialize filter context, filter actor, F gameplay target data filter handle, filter equals T shared PTR F gameplay target data filter, new filter, return filter handle, up arrow back to top. 4.11.4 Gameplay Ability World Reticles. A Gameplay Ability World Reticles, visualize who you are targeting when targeting with non-instant confirmed target actors. Target actors are responsible for the spawn and destroy lifetimes for all reticles. Reticles are A actors so they can use any kind of visual component for representation. A common implementation as seen in GAS Shooter is to use a widget component to display a UMG widget in screen space, always facing the player's camera. Reticles do not know which A actor that they're on, but you could subclass in that functionality on a custom target actor. Target actors will typically update the reticle's location to the target's location on every tick. JS Shooter uses reticles to show locked-on targets for the rocket launcher's secondary abilities homing rockets. The red indicator on the enemy is the reticle. The similar white image is the rocket launcher's crosshair. Reticles in GAS Shooter. Reticles come with a handful of blueprint implementable events for designers. They're intended to be developed in blueprints / called whenever B is target valid changes value. / a function, blueprint implementable event, category equals reticle, void on valid target changed, bool b new value, / called whenever B is target an actor changes value. * a function, blueprint implementable event, category equals reticle, void on targeting an actor, bool b new value, a function, blueprint implementable event, category equals reticle, void on parameters initialized, a function, blueprint implementable event, category equals reticle, void set reticle material perm float, f name perm name, float value, a function, blueprint implementable event, category equals reticle, void set reticle material perm vector, f name perm name, f vector value. Reticles can optionally use f world reticle parameters provided by the target actor for configuration. The default struct only provides one variable f vector AOE scale. While you can technically subclass this struct, the target actor will only accept the base struct. It seems a little short-sighted to not allow this to be subclassed with default target actors. However, if you make your own custom target actor, you can provide your own custom reticle parameter struct and manually pass it to your subclass of a gameplay ability world reticles when you spawn them. Reticles are not replicated by default, but can be made replicated if it makes sense for your game to show other players who the local player is targeting. Reticles will only display on the current valid target with the default target actors. For example, if you're using a agameplay ability target actor _ single line trace to trace for a target, the reticle will only appear when the enemy is directly in the trace path. If you look away, the enemy is no longer a valid target and the reticle will disappear. If you want the reticle to stay on the last valid target, you will want to customize your target actor to remember the last valid target and keep the reticle on them. I refer to these as persistent targets as they will persist until the target actor receives confirmation or cancellation, the target actor finds a new valid target in its trace/overlap, or the target is no longer valid, destroyed. JS Shooter uses persistent targets for its rocket launcher's secondary abilities homing rockets targeting. Up arrow back to top 4.11.5 Gameplay Effect Containers. Targeting gameplay effect containers come with an optional, efficient means of producing target data. This targeting takes place instantly when the effect container is applied on the client and the server. It's more efficient than target actors because it runs on the CDO of the targeting object, no spawning and destroying of actors, but it lacks player input, happens instantly without needing confirmation, cannot be cancelled, and cannot send data from the client to the server, produces data on both. It works well for instant traces and collision overlaps. Epic's Action RPG sample project includes 2 example types of targeting with its containers, target the ability owner and pull target data from an event. It also implements one in Blueprint to do instant sphere traces at some offset, set by child Blueprint classes, from the player. You can subclass URPG target type in C++ or Blueprint to make your own targeting types. Up arrow back to top 5. Commonly implemented abilities and effects. 5.1 Stun. Typically with stuns, we want to cancel all of a character's active gameplay abilities, prevent new gameplay ability activations, and prevent movement throughout the duration of the stun. The sample project's Meteor gameplay ability applies a stun on hit targets. To cancel the target's active gameplay abilities, we call ability system component -cancel abilities, when the stun gameplay tag is added. To prevent new gameplay abilities from activating while stunned, the gameplay abilities are given the stun gameplay tag in their activation blocked tags gameplay tag container. To prevent movement while stunned, we override the character movement component's getMaxSpeed function to return 0 when the owner has the stun gameplay tag. Up arrow back to top 5.2 Sprint. The sample project provides an example of how to sprint, run faster while left shift is held down. The faster movement is handled predictively by the character movement component by sending a flag over the network to the server. See GD character movement component.h/cpp for details. The GA handles responding to the left shift input, tells the CMC to begin and stop sprinting, and to predictively charge stamina while left shift is pressed. See GA_sprint_BP for details. Up arrow back to top 5.3 Aim down sights. The sample project handles this the exact same way as sprinting but decreasing the movement speed instead of increasing it. See GD character movement component.h/cpp for details on predictively decreasing the movement speed. See GA_aim down sight_BP for details on handling the input. There is no stamina cost for aiming down sights. Up arrow back to top 5.4 Lifesteal. I handle lifesteal inside of the damage execution calculation. The gameplay effect will have a gameplay tag on it like effect.can lifesteal. The execution calculation checks if the gameplay effect spec has that effect.can lifesteal gameplay tag. If the gameplay tag exists, the execution calculation creates a dynamic instant gameplay effect with the amount of health to give as the modifier and applies it back to the source's ASC. If spec asset tags.has tag, f gameplay tag request gameplay tag, f name, effect, damage.can lifesteal, float lifesteal equals damage *lifesteal %, u gameplay effect *g lifesteal equals new object u gameplay effect, get transient package, f name, text, lifesteal, g lifesteal dash iteration policy equals e gameplay effect duration type, instant. Int 32 idx equals g lifesteal dash modifiers, number, g lifesteal dash modifiers dot set number, idx +1, f gameplay modifier info and info equals g lifesteal dash modifiers, idx, info dot modifier magnitude equals. F scalable float, lifesteal, info dot modifier op equals e gameplay mod op, additive, info, attribute equals UPA attribute set base, get health attribute, source ability system component dash apply gameplay effect to self, g lifesteal, 1.0 f, source ability system component dash make effect context. Up arrow back to top 5.5 generating a random number on client and server. Sometimes you need to generate a random number inside of a gameplay ability for things like bullet recoil or spread. The client and the server will both want to generate the same random numbers. To do this, we must set the random seed to be the same at the time of gameplay ability activation. You will want to set the random seed each time you activate the gameplay ability in case the client mispredicts activation and its random number sequence becomes out of sync with the server's. Seed setting method description. Use the activation prediction key. The gameplay ability activation prediction key is an int16 guaranteed to be synchronized and available in both the client and server in the activation. You can set this as the random seed on both the client and the server. The downside to this method is that the prediction key always starts at 0 each time the game starts and consistently increments the value to use between generating keys. This means each match will have the exact same random number sequence. This may or may not be random enough for your needs. Send a seed through an event payload. When you activate the gameplay ability, activate your gameplay ability by event and send the randomly generated seed from the client to the server via the replicated event payload. This allows for more randomness, but the client could easily hack their game to only send the same seed value every time. Also, activating gameplay abilities by event will prevent them from activating from the input bind. If your random deviation is small, most players won't notice that the sequence is the same every game, and using the activation prediction key as the random seed should work for you. If you're doing something more complex that needs to be hacker-proof, perhaps using a server-initiated gameplay ability would work better, where the server can create the prediction key or generate the random seed to send via an event payload. Up arrow back to top 5.6 critical hits. I handle critical hits inside of the damage execution calculation. The gameplay effect will have a gameplay tag on it like effect.canCrit. The execution calculation checks if the gameplay effect spec has that effect.canCrit gameplay tag. If the gameplay tag exists, the execution calculation generates a random number corresponding to the critical hit chance, attribute captured from the source, and adds the critical hit damage, also an attribute captured from the source, if it succeeded. Since I don't predict damage, I don't have to worry about synchronizing the random number generators on the client and server, since the execution calculation will only run on the server. If you tried to do this predictively using an MMC to do your damage calculation, you would have to get a reference to the random seed from the gameplay effect spec-gameplay effect context-gameplay ability instance. See how GS Shooter does headshots. It's the same concept except that it does not rely on a random number for chance and instead checks the F hit result bone name. Up arrow back to top 5.7 non-stacking gameplay effects, but only the greatest magnitude actually affects the target. Slow effects in Paragon did not stack. Each slow instance applied and kept track of their lifetimes as normal, but only the greatest magnitude slow effect actually affected the character. GAS provides for this scenario out of the box with Aggregator Evaluate Metadata. See Aggregator Evaluate Metadata for details and implementation. Up arrow back to top 5.8 generate target data while game is paused. If you need to pause the game while waiting to generate target data from a wait target data ability task from your player, I suggest instead of pausing to use slow-mo 0. Up arrow back to top 5.9 one-button interaction system. GS Shooter implements a one-button interaction system where the player can press or hold E to interact with interactable objects like reviving a player, opening a weapon chest, and opening or closing a sliding door. Up arrow back to top 6. Debugging GAS. Often when debugging GAS-related issues, you want to know things like, what are the values of my attributes? What gameplay tags do I have? What gameplay effects do I currently have? What abilities do I have granted, which ones are running, and which ones are blocked from activating? GAS comes with two techniques for answering these questions at runtime: show debug ability system and hooks in a gameplay debugger. Tip: Unreal Engine likes to optimize C++ code, which makes it hard to debug some functions. You will encounter this rarely when tracing deep into your code. If setting your Visual Studio solution configuration to debug game editor still prevents tracing code or inspecting variables, you can disable all optimizations by wrapping the optimized function with the UE_disable_optimization and UE_enable_optimization macros or the ship variations defined in core miscellaneous defines.h. This cannot be used on the plugin code unless you rebuild the plugin from source. This may or may not work on inline functions depending on what they do and where they are. Be sure to remove the macros when you're done debugging. UE_disable_optimization void myClass, myFunction, int 32 myInt parameter, / my code, UE_enable_optimization up arrow back to top 6.1 show debug ability system. Type show debug ability system in the in-game console. This feature is split into 3 pages. All 3 pages will show the gameplay tags that you currently have. Type ability system debug.next category into the console to cycle between the pages. The first page shows the current value of all of your attributes. First page of show debug ability system. The second page shows all of the duration and infinite gameplay effects on you, their number of stacks, what gameplay tags they give, and what modifiers they give. Second page of show debug ability system. The third page shows all of the gameplay abilities that have been granted to you, whether they are currently running, whether they are blocked from activating, and the status of currently running ability tasks. Third page of show debug ability system to cycle between targets, denoted by a green rectangular prism around the actor. Use the page up key or next debug target console command to go to the next target and the page down key or previous debug target console command to go to the previous target. Note, in order for the ability system information to update based on the currently selected debug actor, you need to set BUseDebugTarget from HUD equals true in the ability system globals like so in the default game.ini/script/gameplay abilities.ability system globals, BUseDebugTarget from HUD equals true. Note, for show debug ability system to work, an actual HUD class must be selected in the game mode. Otherwise the command is not found and unknown command is returned. Up arrow back to top 6.2 gameplay debugger. GAS adds functionality to the gameplay debugger. Access the gameplay debugger with the apostrophe key. Enable the abilities category by pressing 3 on your numpad. The category may be different depending on what plugins you have. If your keyboard doesn't have a numpad like a laptop, then you can change the key bindings in the project settings. Use the gameplay debugger when you want to see the gameplay tags, gameplay effects, and gameplay abilities on other characters. Unfortunately, it does not show the current value of the target's attributes. It will target whatever character is in the center of your screen. You can change targets by selecting them in the world outliner in the editor or by looking at a different character and press apostrophe again. The currently inspected character has the largest red circle above it. Gameplay debugger up arrow back to top 6.3 GAS logging. The GAS source code contains a lot of logging statements produced at varying verbosity levels. You will most likely see these as ability_log statements. The default verbosity level is display. Anything higher will not be displayed in the console by default. To change the verbosity level of a log category, type into your console, log, category, verbosity. For example, to turn on ability_log statements, you would type into your console, log ability system very verbose. To reset it back to default, type, log ability system display. To display all log categories, type, log list notable GAS related logging categories. Logging category default verbosity level log ability system display log ability system component log gameplay queue details log gameplay queue translator display log gameplay effect details log gameplay effects display log gameplay tags log gameplay tasks log vlog ability system display. See the wiki on logging for more information. Up arrow back to top 7. Optimization 7.1 ability batching. Gameplay abilities that activate, optionally send target data to the server, and end all in one frame can be batched to condense 2-3 RPCs into 1 RPC. These types of abilities are commonly used for hitscan guns. 7.2 Gameplay queue batching. If you're sending many gameplay queues at the same time, consider batching them into one RPC. The goal is to reduce the number of RPCs. Gameplay queues are unreliable net multicasts, and send as little data as possible. 7.3 Ability System Component Replication Mode. By default, the ASC is in full replication mode. This will replicate all gameplay effects to every client, which is fine for a single-player game. In a multiplayer game, set the player-owned ASCs to mixed replication mode and AI-controlled characters to minimal replication mode. This will replicate GEs applied on a player character to only replicate to the owner of that character, and GEs applied on AI-controlled characters will never replicate GEs to clients. Gameplay tags will still replicate and gameplay queues will still be unreliable net multicast to all clients, regardless of the replication mode. This will cut down on network data from GEs being replicated when all clients don't need to see them. 7.4 Attribute Proxy Replication. In large games with many players like Fortnite Battle Royale, FNBR, there will be a lot of ASCs living on always relevant player states replicating a lot of attributes. To optimize this bottleneck, Fortnite disables the ASC and its attribute sets from replicating altogether on simulated player-controlled proxies in the player state. Replicate subobjects. Autonomous proxies and AI-controlled pawns still fully replicate according to their replication mode. Instead of replicating attributes on the ASC on the always relevant player states, FNBR uses a replicated proxy structure on the player's pawn. When attributes change on the server's ASC, they are changed on the proxy struct too. The client receives the replicated attributes from the proxy struct and pushes the changes back into its local ASC. This allows attribute replication to use the pawn's relevancy and net update frequency. This proxy struct also replicates a small whitelisted set of gameplay tags in a bitmask. This optimization reduces the amount of data over the network and allows us to take advantage of pawn relevancy. AI-controlled pawns have their ASC on the pawn which already uses its relevancy, so this optimization is not needed for them. I'm not sure if it is still necessary with other server-side optimizations that have been done since then, replication graph, etc., and it is not the most maintainable pattern. Dave Ratty from Epic's answer to community questions number 3. 7.5 ASC Lazy Loading. Fortnite Battle Royale, FNBR, has a lot of damageable A actors, trees, buildings, etc., in the world, each with an ASC. This can add up in memory cost. FNBR optimizes this by lazily loading ASCs only when they're needed, when they first take damage by a player. This reduces overall memory usage since some A actors may never be damaged in a match. Up arrow back to top 8. Quality of life suggestions. 8.1 Gameplay Effect Containers. Gameplay Effect Containers combine gameplay effect specs, target data, simple targeting, and related functionality into easy-to-use structures. These are great for transferring gameplay effect specs to projectiles spawned from an ability that will then apply them on collision at a later time. 8.2 Blueprint Async Tasks to bind to ASC delegates to increase designer-friendly iteration times, especially when designing UMG widgets for UI. Create Blueprint Async Tasks in C++ to bind to the common change delegates on the ASC directly from your UMG blueprint graphs. The only caveat is that they must be manually destroyed, like when the widget is destroyed, otherwise they will live in memory forever. The sample project includes 3 blueprint async tasks. Listen for attribute changes, listen for attributes changes BP node, listen for cooldown changes, listen for cooldown change BP node, listen for GE stack changes, listen for gameplay effect stack change BP node. Up arrow back to top 9. Troubleshooting 9. 1 Log ability system. Warning, can't activate local only or local predicted ability %s when not local. You need to initialize the ASC on the client. Up arrow back to top 9.2 Script struct cache errors. You need to call uAbility system globals, init global data. Up arrow back to top 9.3 Animation montages are not replicating to clients. Make sure that you're using the playMontage nwait blueprint node instead of playMontage in your gameplay abilities. This ability task replicates the montage through the ASC automatically, whereas the playMontage node does not. Up arrow back to top 9.4 Duplicating blueprint actors is setting attribute sets to null. There is a bug in Unreal Engine that will set attribute set pointers on your classes to null for blueprint actor classes that are duplicated from existing blueprint actor classes. There are a few workarounds for this. I've had success not creating bespoke attribute set pointers on my classes, no pointer in the .h, not calling create default subobject in the constructor, and instead just directly adding attribute sets to the ASC and post-initialize components, not shown in the sample project. The replicated attribute sets will still live in the ASC spawned attributes array. It would look something like this: void AGD player state, post-initialize components, super, post-initialize components, if, ability system component dash add set UGD attribute set base, // any other attribute sets that you may have. In this scenario, you would read and set the values in the attribute set using the functions on the ASC instead of calling functions on the attribute set made from the macros. *** returns current, final, value of an attribute / float get numeric attribute, const f gameplay attribute and attribute, const, / sets the base value of an attribute. Existing active modifiers are not cleared and will act upon the new base value. */ void set numeric attribute base, const f gameplay attribute and attribute, float new base value, so the get health would look something like, float AGD player state, get health, const, if, ability system component, return ability system component dash get numeric attribute, UGD attribute set base, get health attribute, return 0.0f, setting, initializing, the health attribute would look something like, const float new health equals 100.0f, if, ability system component dash set numeric attribute base, UGD attribute set base, get health attribute, new health. As a reminder, the ASC only ever expects at most one attribute set object per attribute set class. Up arrow back to top 9.5 unresolved external symbol UE push model private, mark property dirty, int, if you get a compiler error like, error LNK 2019, unresolved external symbol, underscore decal spec, blimport, void underscore decal UE push model private, mark property dirty, int, underscore imp underscore. Mark property dirty at UE push model private at yxhh at z, referenced in function, public, void underscore decal f fast array serializer, increment array replication key, void, increment array replication key at f fast array serializer at qaxxc. This is from trying to call mark item dirty on a f fast array serializer. I've encountered this from updating an active gameplay effect such as when updating the cooldown duration. Active gameplay effects.mark item dirty, *ag, what's happening is that with underscore push underscore model is getting defined in more than one place. Push model macros.h is defining it as 0 while it's defined as 1 in multiple places. Push model.h is seeing it as 1 but push model.cpp is seeing it as 0. The solution is to add netcore to your project's public dependency module names in the build.cs. Up arrow back to top 9.6 enum names are now represented by path name if you get a compiler warning like, warning C4996, F gameplay ability input binds, enum names are now represented by path names. Please use a version of F gameplay ability input binds constructor that accepts F top level asset path. Please update your code to the new API before upgrading to the next release, otherwise your project will no longer compile. UE 5.1 deprecated using fstring in the constructor for bind ability activation to input component. Instead, we must pass in an F top level asset path. Old, deprecated way, ability system component dash bind ability activation to input component, F gameplay ability input binds, fstring, confirm target, fstring, cancel target, fstring, EGD ability input ID, static underscore cast int 32, EGD ability input ID, confirm, static underscore cast int 32, EGD ability input ID, cancel, new way, F top level asset path ability enum asset path equals F top level asset path, F name, /script /JS documentation, F name, EGD ability input ID, ability system component dash. Bind ability activation to input component, F gameplay ability input binds, fstring, confirm target, fstring, cancel target, ability enum asset path, static underscore cast int 32, EGD ability input ID, confirm, static underscore cast int 32, EGD ability input ID, cancel. See engine /source /runtime /core uobject /public /uobject /top level asset path.h for more info. Up arrow back to top 10. Common gas acronyms name acronyms ability system component ASC ability task at action RPG sample project by Epic ARPG sample character movement component CMC gameplay ability GA gameplay ability system gas gameplay Q GC gameplay effect GE gameplay effect execution calculation exec execution gameplay tag GT modifier magnitude calculation mod mag calc MMC up arrow back to top 11. Other resources official documentation source code. Especially gameplay prediction.h Lyra sample project by Epic Action RPG sample project by Epic Unreal Slackers Discord has a text channel dedicated to gas hashtag gameplay ability system check pinned messages GitHub repository of resources by Dan Pan YouTube videos by SaberDart Studios 11.1 Q&A with Epic Games Dave Ratty 1.1.1 community questions 1 Dave Ratty responses to the Unreal Slackers Discord server community questions about gas. How can we create scoped prediction windows on demand outside or irrespective of gameplay abilities? For example, how can a fire and forget projectile locally predict a damage gameplay effect when it hits an enemy? The prediction key system is not really meant to do this. Fundamentally this system works by a client initiating a predictive action, telling the server about it with a key, and then both client and server running the same thing and associating predictive side effects with the given prediction key. For example, I am predictively activating an ability, or I have produced target data and am going to predictively run the part of the ability graph after the wait target data task. With this pattern, the prediction key bounces off the server and comes back to the client by uability system component, replicated prediction key map, replicated property. Once the key is replicated back from the server, the client is able to undo all of the locally predictive side effects, gameplay cues, gameplay effects. The replicated versions will be there, and if they aren't then it was a misprediction. Knowing exactly when to undo the predictive side effects is crucial here. If you are too early you will see gaps, if you are too late you will have double. Note this is referring to stateful prediction, like a looping gameplay cue of a duration-based gameplay effect. Burst gameplay cues and instant gameplay effects are never undone or rolled back. They are just skipped on the client if there is a prediction key associated with them. To further hit home the point, it's crucial that predictive action is something the server does not do on their own, but only does so when the client tells them to. So having a generic, create a key on demand and tell the server so I can run something, does not work unless that something is something the server will only do once told to by the client. Backing up to the original question, something like a fire and forget projectile. Both Paragon and Fortnite have projectile actor classes that use gameplay cues. However, we do not use the prediction key system to do these. Instead, we have a concept on non-replicated gameplay cues. Gameplay cues that just fire off locally and are skipped by the server completely. Essentially, all these are direct calls to uGameplay Queue Manager, handle gameplay queue. They do not route through the uAbility system component, so no prediction key checks/early returns are made. The downside with non-replicated gameplay cues is that, well, they are not replicated. So it's up to the projectile class/blueprint to make sure the code paths that call these functions are running on everyone. We have for queue startup, called in begin play, explosion, hit wall/character, etc. These type of events are already generated client-side, so calling into a non-replicated gameplay queue was no big deal. Complicated blueprints can be tricky, and are up to the author to make sure they understand what is running where. When using a waitnet sync ability task with only server wait to create a scoped prediction window in a locally predicted gameplay ability, could players potentially cheat by delaying their packets to the server to control gameplay ability timing since the server is waiting for their RPC with their prediction key? Was this ever an issue in Paragon or Fortnite, and if so, what did Epic do to remedy it? Yes, this is a valid concern. Any ability blueprint running on the server that is waiting for a client signal is potentially vulnerable to lag switch type exploits. Paragon had a custom targeting task similar to uAbility task_wait target data. In this task we had timeouts, or a max delay, that we would wait on the client for instantaneous targeting modes. If the targeting mode was waiting for user confirmation, button press, then it would be ignored since the user is allowed to take his time. But for abilities that instantly confirmed targeting we would only wait a certain amount of time before either A, generating the target data server side, or B, cancelling the ability. We never had such mechanisms for waitnet sync, which we used pretty sparingly. I don't believe Fortnite makes use of anything like this though. The weapon abilities in Fortnite are special cased batched to a single Fortnite-specific RPC, one RPC to activate the ability, provide target data, and end the ability. So weapon abilities are intrinsically not vulnerable to this in Battle Royale. My take is that this is something that could probably be solved system-wide, but I don't see us making the change ourselves anytime soon. Spot fixing waitnet sync to include a max delay for the case you mention is probably a reasonable task, but again, unlikely we will do this on our end in the immediate future. Which gameplay effect replication mode did Paragon and Fortnite use, and what are Epic's recommendations for when to use each? Both games essentially use mixed mode for their player-controlled characters and minimal for AI-controlled, AI minions, jungle creeps, AI husks, etc. This is what I would recommend most people using the system in a multiplayer game. The sooner into your project you set these, the better. Fortnite goes a few steps further with its optimizations. It actually does not replicate the uAbility system component at all for simulated proxies. The component and attribute subobjects are skipped inside replicate subobjects on the owning Fortnite player state class. We do push the bare minimum replicated data from the ability system component to a structure on the pawn itself, basically, a subset of attribute values and a whitelist subset of tags that we replicate down in a bitmask. We call this a proxy. On the receiving side we take the proxy data, replicated on the pawn, and push it back into ability system component on the player state. So you do have an ASC for each player in FNBR, it just doesn't directly replicate, instead it replicates data via a minimal proxy struct on the pawn and then routes back to the ASC on receiving side. This is advantage since it's a more minimal set of data. B, takes advantage of pawn relevancy. I'm not sure if it is still necessary with other server-side optimizations that have been done since then, replication graph, etc., and it is not the most maintainable pattern. Since we cannot predict the removal of gameplay effects as per gameplay prediction.h, are there any strategies for mitigating the effects of latency on removing gameplay effects? For example, when removing a movement speed slow, we currently have to wait for the server to replicate the gameplay effect removal resulting in a snap of the player's character position. This is a tough one and I don't have a good answer. We generally skirted around these problems with tolerances and smoothing. I totally agree that ability system and precise synchronization with the character movement system is not in a good place and something we do want to fix. I had a shelf of allowing predictive removal of GEs but could never work out all edge cases before having to move on. This doesn't solve everything though since character movement still has an internal saved move buffer that does not know anything about the ability system and possible movement speed modifiers, etc. It is still possible to get into correction feedback loops even outside of not being able to predict the removal of GEs. If you think you have a case that is truly desperate, you are able to predictively add a GE that would inhibit your movement speed GEs. I've never done this myself but have theorized about it before. It may be able to help with a certain class of problem. We know that the ability system component lives on the player state in Paragon and Fortnite and on the character in the action RPG sample. What are Epic's internal rules, guidelines, or recommendations for where the ability system component should live, and what should its owner be? In general I would say anything that does not need to respawn should have the owner and avatar actor be the same thing. Anything like AI enemies, buildings, world props, etc. Anything that does respawn should have the owner and avatar be different so that the ability system component does not need to be saved off /recreated /restored after a respawn. Player state is the logical choice, it is replicated to all clients, whereas player controller is not. The downside is player states are always relevant, so you can run into problems in 100-player games. See notes on what FN did in question number 3. Is it viable to have several ability system components which have the same owner but different avatars, e.g. on pawn and weapon/items/projectiles with owner set to player state? The first problem I see there would be implementing the iGameplay tag asset interface and iAbility system interface on the owning actor. The former may be possible, just aggregate the tags from all ASCs, but watch out, as all matching gameplay tags may be met only via cross-ASC aggregation. It wouldn't be enough to just forward that calls to each ASC and or the results together. But the later is even trickier, which ASC is the authoritative one? If someone wants to apply a GE, which one should receive it? Maybe you can work these out, but this side of the problem will be the hardest. Owners will multiple ASCs beneath them. Separate ASCs on the pawn and the weapon can make sense on its own though. E.G, distinguishing between tags that describe the weapon versus those that describe the owning pawn. Maybe it does make sense that tags granted to the weapon also apply to the owner and nothing else. E.G, attributes and GEs are independent, but the owner will aggregate the owned tags like I describe above. This could work out, I am sure. But having multiple ASCs with the same owner may get dicey. Is there a way to stop the server from overriding the cooldown duration of locally predicted abilities on the owning client? In scenarios of high latency, this would let the owning client try to activate the ability again when its local cooldown expires, but it is still on cooldown on the server. By the time the owning client's activation request reaches the server over the network, the server may be off cooldown, or the server might be able to queue the activation request for the remaining milliseconds that it has left. Otherwise, as is, clients with higher latency have a longer delay before when they can reactivate an ability versus those with less latency. This is most apparent with very low cooldown abilities like a basic attack that can be less than 1 second of cooldown. If there isn't a way to stop the server from overriding the cooldown duration of locally predicted abilities, what is Epic's strategy for mitigating the effects of high latency on reactivating abilities? To word it another example-based way, how did Epic design Paragon's basic attacks and other abilities so that high latency players could attack or activate at the same speed as low latency players with local prediction? The short answer: there is not a way to prevent this, and Paragon definitely had the problem. Higher latency connections would have a lower ROF with basic attacks. I attempted to fix this by adding GE reconciliation, where latency was taken into account when calculating GE duration. Essentially allowing the server to eat some of the total GE time so that the effective time of the GE client side would be 100% consistent with any amount of latency, though fluctuations could still cause issues. However, I never got this working in a state that could ship, and the project moved fast and we just never fully addressed it. Fortnite does its own bookkeeping for weapon firing rates. It does not use GEs for cooldowns on weapons. I would recommend this if this is a critical problem for your game. What is Epic's roadmap for the Gameplay Ability System plugin? Which features does Epic plan to add in 2019 and beyond? We feel that overall the system is pretty stable at this point, and we don't have anyone working on major new features. Bug fixes and small improvements occasionally are made for Fortnite or from UDN/pull requests, but that is it right now. Longer term, I think we will eventually do a V2 or some big changes. We learned a lot from writing this system and feel we got a lot right and a lot wrong. I would love a chance to correct those mistakes and improve some of the fatal flaws that were pointed out above. If a V2 was to ever come, providing an upgrade path would be of utmost importance. We would never make a V2 and leave Fortnite on V1 forever. There would be some path or procedures that would automatically migrate as much as possible, though there would still almost certainly be some manual remaking required. The high priority fixes would be better interoperability with the character movement system, unifying client prediction, GE removal prediction, question number 4, GE latency reconciliation, question number 7, generalized network optimizations such as batching RPCs and proxy structures. Mostly the stuff that we've done for Fortnite, but find ways to break it down into more generalized form, at least so that games can write their own game-specific optimizations more easily. The more general refactor type of changes I would consider making, I would like to look at fundamentally moving away from having GEs reference spreadsheet values directly. Instead they would be able to emit parameters, and those parameters could be filled by some higher level object that is bound to spreadsheet values. The problem with the current model is that GEs become unshareable due to their tight coupling with the curve table rows. I think a generalized system for parameterization could be written and be the underpinning of a V2 system. Reduce number of policies on gameplay ability. I would remove replication policy and instancing policy. Replication is, IMO, almost never actually needed and causes confusion. Instancing policy should be replaced instead by making gameplay ability spec a U object that can be subclassed. This should have been the non-instantiated ability object that has events and is blueprintable. The gameplay ability should be the instance per execution object. It could be optional if you need to actually instantiate. Instead, non-instanced abilities would be implemented via the new gameplay ability spec object. The system should provide more middle-level constructs such as filter GE application container, data drive what GEs to apply to which actors with higher-level gameplay logic, overlapping volume support, apply the filter GE application container based on collision primitive overlap events, etc. These are building blocks that every project ends up implementing in their own way. Getting them right is non-trivial, so I think we should do a better job providing some basic implementations. In general, reducing boilerplate needed to get your project up and running. Possibly a separate module, X library, or whatever that could provide things like passive abilities or basic hitscan weapons out of the box. This module would be optional but would get you up and running quickly. I would like to move gameplay queues to a separate module that is not coupled with the ability system. I think there are a lot of improvements that could be made here. This is only my personal opinion and not a commitment from anyone. I think the most realistic course of action will be as new engine tech initiatives come through, the ability system will need to be updated and that will be a time to do this sort of thing. These initiatives could be related to scripting, networking, or physics/character movement. This is all very far looking ahead though, so I cannot give commitments or estimates on timelines. Up arrow back to top 1.1.2 community questions. 2 community member Insights Q&A with Dave Ratty. Is the support for decoupled fixed ticking planned? I'd like to have game thread be fixed, like 30/60 FPS, and let the rendering thread run wild. I ask if this is something we should expect in future or not, to make some assumptions about how gameplay should work. I ask mainly because there is now a fixed async tick for physics and this poses a question how the rest of the system might work in the future. I do not hide that having the ability to have fixed tick game thread without also fixing tick rate of the rest of the engine would be beyond awesome. There are no plans to decouple rendering frame rate and game thread tick frame rate. I think the ship has sailed on this ever happening due to the complexity of these systems and the requirement to preserve backwards compatibility with previous engine versions. Instead, the direction we've gone is to have an asynchronous physics thread which runs at a fixed tick rate, independent of the game thread. Things that need to run at a fixed rate can run here and the game thread/rendering can operate how they always have. It's worth clarifying that network prediction supports what it calls independent ticking and fixed ticking modes. My long-term plan is to keep independent ticking roughly how it is today in network prediction, where it runs on the game thread at variable frame rate and there is no group/world prediction, it's just the classic clients predict their own pawn and owned actors model. And fixed ticking would be what uses the async physics stuff and allows you to predict non-client controlled/owned actors like physics objects and other clients/pawns/vehicles/etc. Is there any plan on how the integration of network prediction will look with the ability system? Like for example, fixed frame ability activation, so the server gets frames in which abilities were activated and tasks executed instead of prediction keys. Yes, the plan is to rewrite/remove the ability system's prediction keys and replace them with network prediction constructs. The mock ability examples in network prediction extras show how this might work, but they are more hard-coded than what GAS will require. The main idea would be that we remove the explicit client-server prediction key exchange in the ASC's RPCs. There would no longer be prediction windows or scoped prediction keys. Instead, everything would be anchored around network prediction frames. The important thing is that client and server agree on when things happen. Examples would be, when abilities were activated/ended/cancelled, when gameplay effects were applied/removed attribute values, what an attribute's value was at frame X. I think this could be done generically at the ability system level. But actually making the user-defined logic inside a U-gameplay ability completely rollbackable would still take more work. We may end up having a subclass of U-gameplay ability that is fully rollbackable and has access to a more limited set of functionality or only ability tasks that are marked as rollback friendly. Something like that. There are also many implications to animation events and root motion and how those are processed. Wish I had a more clear answer, but it's really important we get the foundation right before touching gas again. Movement and physics have to be solid before the higher level systems can be changed. Is there a plan to move network prediction development toward the main branch? Not gonna lie, I'd really like to check the latest code. Regardless of its state. We are working towards it. The system work is still all being done in network prediction, see networkphysics.h, and the underlying async physics stuff should be all available, rewinddata.h etc. But we also have use cases in Fortnite that we have been focused on that obviously can't be made public. We are working through bugs, performance optimizations, etc. For more context, when working on the early versions of this system, we were very focused on the front end of things, how state and simulations were defined and written. We learned a lot there. But as the async physics stuff has come online, we've been much more focused on just getting something real to work in this system, at the expense of throwing out some of our early abstractions. The goal here is to circle back when the real thing is working and reunifying things. E.g, get back to the front end and make the final version of that on top of the core pieces of tech we are working on now. For some time on main branch there was a plugin for sending gameplay messages, looked like event/message bus, but it was removed. Any plans to restore it? With the game features/modular gameplay plugins, having a generic event bus dispatcher would be extremely useful. I think you are referring to the gameplay messages plugin. This will probably come back at some point. The API isn't really finalized yet and the author didn't mean for it to be public yet. I agree it should be useful for modular gameplay design. But it's not really my area, so I don't have much more information. I've been playing recently with async fixed physics and the results are promising, though if there is going to be NP update in the future I will probably just play around and wait, since to get it working I still need to get entire engine into fixed tick, and on the other hand I try to keep physics at 33 milliseconds. Which does not make for a good experience if everything is at 30 frames per second, smiley face. I have noticed there was some work on async character movement component, but not sure if this will be using network prediction, or it is a separate effort. Since I noticed it, I also went ahead and tried to implement my custom async movement at fixed tick rate, which worked okay, but on top of it I also needed to add a separate update for interpolation. The setup was to run simulation tick on separate worker threads at fixed 33 milliseconds update, do calculations, save result, and interpolate it at the game thread to match current frame rate. Not perfect, but it got the job done. My question is, if this is something that might be easier to set up in the future, as there is just quite a bit of boilerplate code to write, the interpolation part, and it's not particularly efficient to interpolate each moving object individually. The async stuff is really interesting, because it would allow you to really run game simulation at fixed update rate, which would make fixed thread unneeded, and have more predictable results. Is this something that is intended going forward, or more of a benefit to select systems? As far as I remember, actor transforms are not updated async and blueprints are not entirely thread safe. In other words, is it something that is planned to be supported at more of a framework level or something that each game has to solve on its own? Async character movement component. This is basically an early prototype/experiment of porting CMC as it is to the physics thread. I don't view it as the future of CMC yet, but it could evolve into that. Right now there is no networking support, so it's not something I would really follow. The people doing it are mostly concerned with measuring input latency that this system would add and how that could be mitigated. I still need to get entire engine into fixed tick, and on the other hand I try to keep physics at 33 milliseconds. Which does not make for a good experience if everything is at 30 frames per second, smiley face. The async stuff is really interesting, because it would allow you to really run game simulation at fixed update rate, which would make fixed thread unneeded, yes. The goal here is that with async physics enabled, you can run the engine at variable tick rate while the physics and core gameplay simulations can run at the fixed rate, such as character movement, vehicles, gas, etc. These are the kvars that need to be set to enable this now. I think you figured this out. P.default async dt equals 0.03333 P.rewind capture number frames equals 64 chaos does provide interpolation for the physics state, e.g., the transforms that get pushed back to the uprimitive component and are visible to the game code. There is a kvar now, P.async interpolation multiplier, which controls that if you want to look at it. You should see smooth continuous motion of physics bodies without having to write any extra code. If you want to interpolate non-physics state, it is still up to you to do that right now. The example would be like a cooldown that you want to update, tick, on the async physics thread but see smooth continuous interpolation on the game thread so that every render frame the cooldown visualization is updated. We will get to this eventually but don't have examples yet. There is just quite a bit of boilerplate code to write, yeah, so that has been a big general problem with the system up until now. We want to provide an interface that experienced programmers can use to maximize performance and safety, the ability to write gameplay code that just works predictably without tons of hazards and things you could do but better not. So something like character movement might do a bunch of custom stuff to maximize its performance, e.g., writing templated code and doing batch updating, going wide, breaking the update loop into distinct phases, etc. We want to provide a good, low-level interface into the async thread and rollback systems for this use case. And in this case too, it's still reasonable that the character movement system itself is extendable in its own way. So I think there will be some form of this one day. But again, we aren't there yet. I realize you were just asking about interpolation, but that is the general answer. Right now we have you do everything manually like net serialize, should reconcile, interpolate, etc. But eventually we'll have a way that is like, if you want to just use the reflection system, you don't have to manually write this stuff. We just don't want to force everyone to use the reflection system since that imposes other limitations that we think we don't want to take on the lowest levels of the system. And then just to tie this back to what I said earlier, right now we are really focused on getting a few very specific examples working and performant, and then we will turn attention back to the front end and making things friendly to use and iterate on, reducing boilerplate, etc. for everybody else to use. Up arrow back to top 12. Gas changelog. This is a list of notable changes, fixes, changes, and new features to Gas compiled from the official Unreal Engine upgrade changelog and from undocumented changes that I've encountered. If you found something that isn't listed here, please make an issue or pull request. 5.3 Crash fix, fixed a crash when trying to apply gameplay cues after a seamless travel. Crash fix, fixed a crash caused by global ability task count when using live coding. Crash fix, fixed U-ability task, on destroy to not crash if called recursively for cases like U-ability task _ start ability state. Bug fix, it is now safe to call super, activate ability in a child class. Previously, it would call commit ability. Bug fix, added support for properly replicating different types of F gameplay effect context. Bug fix, F gameplay effect context handle will now check if data is valid before retrieving actors. Bug fix, retain rotation for gameplay ability system target data location info. Bug fix, gameplay ability system now stop searching for PC only if a valid PC is found. Bug fix. Use existing gameplay queue parameters if it exists instead of default parameters object in remove gameplay queue _ internal. Bug fix, gameplay ability world reticle now faces towards the source actor instead of the targeting actor. Bug fix, cache trigger event data if it was passed in with give ability and activate once and the ability list was locked. Bug fix, support has been added for the F inherited gameplay tags to update its combined tags immediately rather than waiting until a save. Bug fix, moved should ability respond to event from client-only code path to both server and client. Bug fix, fixed F attribute set initter discrete levels from not working in cooked builds due to curve simplification. Bug fix, set current event data in gameplay ability. Bug fix, ensure minimal replication tags are set up correctly before potentially executing callbacks. Bug fix, fixed should ability respond to event from not getting called on the instanced gameplay ability. Bug fix, gameplay queue notify actors executing on child actors no longer leak memory when gc.pending kill is disabled. Bug fix, fixed an issue in gameplay queue manager where gameplay queue notify _ actors could be lost due to hash collisions. Bug fix, wait gameplay tag query will now respect its query even if we have no gameplay tags on the actor. Bug fix, post attribute change and attribute value change delegates will now have the correct old value. Bug fix, fixed F gameplay tag query from not showing a proper query description if the struct was created by native code. Bug fix, ensure that the U-ability system globals, init global data is called if the ability system is in use. Previously if the user did not call it, the gameplay ability system did not function correctly. Bug fix, fixed issue when linking/unlinking anim layers from U-gameplay ability, end ability. Bug fix, updated ability system component function to check the specs ability pointer before use. New, added a gameplay tag query field to F gameplay tag requirements to enable more complex requirements to be specified. New, introduced F gameplay effect query, source aggregate tag query to augment source tag query. New, extended the functionality to execute and cancel gameplay abilities and gameplay effects from a console command. New, added the ability to perform an audit on gameplay ability blueprints that will show information on how they're developed and intended to be used. Change, on avatar set is now called on the primary instance instead of the CDO for instance per actor gameplay abilities. Change, allow both activate ability and activate ability from event in the same gameplay ability graph. Change, anim task _ play montage and wait now has a toggle to allow completed and interrupted after a blend out event. Change, mod magnitude calc wrapper functions have been declared constant change, F gameplay tag query matches now returns false for empty queries. Change, updated F gameplay attribute, post serialized to mark the contained attribute as a searchable name. Change, updated getAbility system component to default parameter to self. Change, marked functions as virtual in ability task _ wait target data. Change, removed and used function F gameplay ability target data, add target data to gameplay queue parameters. Change, removed vestigial gameplay ability, set movement sync point. Change, removed and used replication flag from gameplay tasks and ability system components. Change, moved some gameplay effect functionality into optional components. All existing content will automatically update to use components during post-CDO compiled, if necessary. https://docs.unreal-engine.com/5.3/and-us/unreal-engine-5.3-release-notes 5.2 bug fix, fixed a crash in the U-ability system blueprint library, make spec handle function. Fixed a bug that would cause gameplay queues to get stuck on remote instances. Bug fix, fixed a memory stomp when chaining calls to wait gameplay event. Bug fix, calling the ability system component getOwn gameplay tags, function in blueprint no longer retains the previous call's return values when the same node is executed multiple times. Bug fix, fixed an issue with gameplay effect context replicating a reference to a dynamic object that would never be replicated. This prevented gameplay effect from calling owner-handle deferred gameplay queues. This, as B has more unmapped references, would always be true. New, the gameplay targeting system is a way to create data-driven targeting requests. New, added custom serialization support for gameplay tag queries. New, added support for replicating derived F gameplay effect context types. New, gameplay attributes and assets are now registered as searchable names on save, allowing for references to attributes to be seen in the reference viewer. New, added some basic unit tests for the ability system component. New, gameplay ability system attributes now respect core redirects. This means you can now rename attribute sets and their attributes in code and have them load properly in assets saved with the old names by adding redirect entries to default engine.ini. Change, allow changing the evaluation channel of a gameplay effect modifier from code. Change, removed previously unused variable F gameplay modifier info magnitude from the gameplay abilities plugin. Change, removed the synchronization logic between the ability system component and smart object instance tags. https://docs.unreal-engine.com/5.2/and-us/unreal-engine-5.2-release-notes 5.1 bug fix, fixed issue where replicated loose gameplay tags were not replicating to the owner. Bug fix, fixed ability task bug where abilities could be blocked from timely garbage collection. Bug fix, fixed an issue when a gameplay ability listening to activate based on a tag would fail to be activated. This would happen if there were more than one gameplay ability listening to this tag, and the first one in the list was invalid or didn't have authority to activate. Bug fix, fixed gameplay effects that use data registries correctly from warning on load and improved the warning text. Bug fix, removed code from U-gameplay ability that was incorrectly only registering the last instanced ability with the blueprint debugger for breakpoints. Bug fix, fixed gameplay ability system ability getting stuck if end ability was called during the lock inside apply gameplay effect spec to target. New, added support for gameplay effects to add blocked ability tags. New, added wait gameplay tag query nodes. One is based off of a uAbility task and the other is of uAbility async. This node specifies a tag query, and will trigger its output pin when the query becomes true or false, based on configuration. New, modified ability task debugging in console variables to enable debug recording and printing to log by default in non-shipping builds, with ability to hotfix on, off as needed. New, you can now set ability system.ability task, debug.recording enabled to 0 to disable, 1 to enable in non-shipping builds, and 2 to enable all builds, including shipping. New, you can use ability system.ability task, debug.ability task debug print top end results to only print the top end results in log, to avoid log spam. New, stat_ability task debug recording can be used to test perf impact from these on by default debugging changes. New, added a debug command to filter gameplay queue events. New, added new debug commands ability system.debug ability tags, ability system.debug block tags, and ability system.debug attribute to the gameplay ability system. New, added a blueprint function to get a debug string representation of a gameplay attribute. New, added a new gameplay task resource overlap policy to cancel existing tasks. Change, now ability tasks should make sure to call super on destroy only after they do anything needed to the ability pointer, as it will be nulled out after calling it. Change, converted f gameplay ability spec/def source object to be a weak reference. Change, made a ability system component reference in the ability task a weak pointer so garbage collection can delete it. Change, removed redundant enum wake gameplay tag pre-async trigger condition. Change, gameplay tasks component and ability system component now support the registered subobject API. Change, added better logging to indicate why gameplay abilities failed to be activated. Change, removed ability system debug.nextTarget and prevtarget commands in favor of global HUD nextDebugTarget and prevDebugTarget commands. https://docs.unrealengine.com/5.1/and-us/unreal-engine-5.1-release-notes 5.0 https://docs.unrealengine.com/5.0-us/unreal-engine-5.0-release-notes 4.27 crash fix. Fixed a root motion source issue where a networked client could crash when an actor finishes executing an ability that uses a constant force root motion task with a strength over time modifier. Bug fix, fixed a regression in editor loading time when using gameplay queues. Bug fix, gameplay effects container set active gameplay effect level method will no longer dirty fast array if setting the same effect level. Bug fix, fixed an edge case in gameplay effect mixed replication mode where actors not explicitly owned by the net connection but who utilize that connection from getNet connection will not receive mixed replication updates. Bug fix, fixed an endless recursion occurring in gameplay abilities class method endAbility which was called by calling endAbility again from K2_on endAbility. Bug fix, gameplay tags blueprint pins will no longer be silently cleared if they are loaded before tags are registered. They now work the same as gameplay tag variables, and the behavior for both can be changed with the clear invalid tags option in the project settings. Bug fix, improved thread safety of gameplay tag operations. New, exposed source object to gameplay abilities K2_can activate ability method. New, native gameplay tags. Introducing a new F-native gameplay tag, these make it possible to do one-off native tags that are correctly registered and unregistered when the module is loaded and unloaded. New, updated giveAbility and activate once to pass in F-gameplay event data parameter. New, improved scalable floats in the gameplay abilities plugin to support dynamic lookup of curve tables from the new data registry system. Added a scalable float header for easier reuse of the generic struct outside the abilities plugin. New, added code support for using the gameplay tag UI in other editor customizations via gameplay tags editor module. New, modified uGameplay abilities pre-activate method to optionally take in trigger event data. New, added more support to filter gameplay tags in the editor using a project-specific filter. OnFilter gameplay tag supplies the referencing property and the tag source, so you can filter tags based on what asset is requesting the tag. New, added option to preserve the original captured source tags when gameplay effect specs class method set context is called after initialization. New, improved UI for registering gameplay tags from specific plugins. The new tag UI now lets you select a plugin location on disk for newly added gameplay tag sources. New, a new track has been added to Sequencer to allow for triggering notify states on actors built using the gameplay ability system. Like notifies, the gameplay queue track can utilize range-based events or trigger-based events. Change the gameplay queue interface to pass gameplay queue parameters struct by reference. Optimization, made several performance improvements to loading and regenerating the gameplay tag table were implemented so that this option would be optimized. https://docs.unrealengine.com/and-us/what's-new/build/release-notes/4_274.26 gas plugin is no longer flagged as beta. Crash fix, fixed a crash when adding a gameplay tag without a valid tag source selection. Crash fix. Added the path string arg to a message to fix a crash in uGameplay Queue Manager, verify notify asset is invalid path. Crash fix, fixed an access violation crash in ability system component_abilities when using a PTR without checking it. Bug fix, fixed a bug where stacking GEs that did not reset the duration on additional instances of the effect being applied. Bug fix, fixed an issue that caused cancel all abilities to only cancel non-instanced abilities. New, added optional tag parameters to gameplay ability commit functions. New, added start time seconds to play montage and wait ability task and improved comments. New, added tag container dynamic ability tags to F gameplay ability spec. These are optional ability tags that are replicated with the spec. They are also captured as source tags by applied gameplay effects. New, gameplay ability is locally controlled and has authority functions are now callable from blueprint. New, visual logger will now only collect and store info about instant GEs if we're currently recording visual logging data. New, added support for redirectors on gameplay attribute pins in blueprint nodes. New, added new functionality for when root motion movement related ability tasks end, they will return the movement component's movement mode to the movement mode it was in before the task started. https://docs.unrealengine.com/and-us/what's-new/build/release notes/4_264.25.1 fixed. UE 92787 crash saving blueprint with a get float attribute node and the attribute pin is set inline fixed. UE 92810 crash spawning actor with instance editable gameplay tag property that was changed inline 4.25 fixed prediction of root motion source ability tasks GMEPLAYATTRIBUT_rep notify now additionally takes in the old attribute value. We must supply that as the optional parameter to our onRep functions. Previously, it was reading the attribute value to try to get the old value. However, if called from a replication function, the old value had already been discarded before reaching set base attribute value from replication, so we get the new value instead. Added net security policy to gameplay ability. Crash fix, fixed a crash when adding a gameplay tag without a valid tag source selection. Crash fix, removed a few ways for attackers to crash a server through the ability system. Crash fix, we now make sure we have a gameplay effect definition before checking tag requirements. Bug fix, fixed an issue with gameplay tag categories not applying to function parameters in blueprints if they were part of a function terminator node. Bug fix, fixed an issue with gameplay effects tags not being replicated with multiple viewports. Bug fix, fixed a bug where a gameplay ability spec could be invalidated by the internal try-activate ability function while looping through triggered abilities. Bug fix, changed how we handle updating gameplay tags inside of tag count containers. When deferring the update of parent tags while removing gameplay tags, we will now call the change-related delegates after the parent tags have updated. This ensures that the tag table is in a consistent state when the delegates broadcast. Bug fix, we now make a copy of the spawn target actor array before iterating over it inside when confirming targets because some callbacks may modify the array. Bug fix, fixed a bug where stacking gameplay effects that did not reset the duration on additional instances of the effect being applied and with set by caller durations would only have the duration correctly set for the first instance on the stack. All other GE specs in the stack would have a duration of 1 second. Added automation tests to detect this case. Bug fix, fixed a bug that could occur if handling gameplay event delegates modified the list of gameplay event delegates. Bug fix, fixed a bug causing give ability and activate once to behave inconsistently. Bug fix. Reordered some operations inside F gameplay effect spec, initialized to deal with a potential ordering dependency. New, U gameplay ability now has an on-remove ability function. It follows the same pattern as on-give ability and is only called on the primary instance of the ability or the class default object. New, when displaying blocked ability tags, the debug text now includes the total number of blocked tags. New, renamed UAbility system component, internal server try-active ability to UAbility system component, internal server try-activate ability, code that was calling internal server try-active ability should now call internal server try-activate ability. New, continue to use the filter text for displaying gameplay tags when a tag is added or deleted. The previous behavior cleared the filter. New, don't reset the tag source when we add a new tag in the editor. New, added the ability to query an ability system component for all active gameplay effects that have a specified set of tags. The new function is called getActiveEffectsWithAllTags and can be accessed through code or blueprints. New, when root motion movement related ability tasks end, they now return the movement component's movement mode to the movement mode it was in before the task started. New, made spawned attributes transient so it won't save data that can become stale and incorrect. Added null checks to prevent any currently saved stale data from propagating. This prevents problems related to bad data getting stored in spawned attributes. API change, add default subobject set has been deprecated. Add attribute set subobject should be used instead. New, gameplay abilities can now specify the anim instance on which to play a montage. https://docs.unrealengine.com/and-us/what's-new/build/release notes/4_254.24 fixed blueprint node attribute variables resetting to none on compile. Need to call UAbility system globals, init global data. To use target data, otherwise you will get script struct cache errors and clients will be disconnected from the server. My advice is to always call this in every project now, whereas before 4.24 it was optional. Fixed crash when copying a gameplay tag setter to a blueprint that didn't have the variable previously defined. UGameplay ability, montage stop, function now properly uses the override blendout time parameter. Fixed gameplay tag query variables on components not being modified when edited. Added the ability for gameplay effect execution calculations to support scoped modifiers against temporary variables that aren't required to be backed by an attribute capture. Implementation basically enables gameplay tag identified aggregators to be created as a means for an execution to expose a temporary value to be manipulated with scoped modifiers. You can now build formulas that want manipulatable values that don't need to be captured from a source or target. To use, an execution has to add a tag to the new member variable valid transient aggregator identifiers. Those tags will show up in the calculation modifier array of scoped mods at the bottom, marked as temporary variables, with updated details customizations accordingly to support feature added restricted tag quality of life improvements. Remove the default option for restricted gameplay tag source. We no longer reset the source when adding restricted tags to make it easier to add several in a row. A pawn, possessed by, now sets the owner of the pawn to the new controller. Useful because mixed replication mode expects the owner of the pawn to be the controller if the ASC lives on the pawn. Fixed bug with pod, plain old data, in F attribute set in discrete levels.